Hi! As I promised, I will now give a quick tour of my quick charging system here on my Zero DSR. To start off, we can see everything is back together. The tank is mounted, the seat is mounted, and down there the charger is also mounted. The only thing that is not mounted, just for now, are my plastics, my side plastics on the sides and the front. My charging system consists of three main parts. First would be the charger itself, or the chargers. They sit down here. The second part is the cooling system. This is threefold. So we have a chill plate that is mounted to the chargers. We have a reservoir with a pump and a radiator. So we have a cooling loop that will take the heat from the chargers and get rid of the heat inside this tank. I will show it a little closer in this video. And the third thing is the control. So we have, let's say, something like a brain box with a controller that will control the chargers via CAN-bus and will also enable the communication to the charging system or to the charging station, and also enable the bike to go into the charge mode and will keep the bike in charge mode even if we turn the bike off. But now I think we should just start with the first thing, and the most important thing is the chargers. Here we can see my new belly pan. It's now powder coated and welded at the seams, or it's welded at the seams and then powder coated. And below this we have our three separate TC chargers with each about 3.3 kilowatts. On this side we will have in this area our DC splice box that takes the DC output of every charger and combines them into those two cables. And this box also features a dedicated fuse with 100 amps. Since everything is already mounted and I don't want to take everything apart again, I will show the German footage and dub it in English. So here we can see our chargers itself without the outer casing or the belly pan. And we have our three main DC charging leads from each charger that go back to our splice box. Well, and I just show now the chill plate itself. And we also can see we have an extra air gap between the chargers or the chill plate and the battery. So we have an extra thermal insulation so no heat gets pushed in the batteries while charging. In the front we can also see a little extra module. This is a temperature control or a fan controller. We will see those fans shortly. Here's the DC splice box opened. We can see all the connections, and we actually have two bus bars. We have a negative one that connects each negative and a positive that connects each positive lead. But there's a difference. Our negative bus bar is a complete bus bar that goes directly to our motor controller, to our main B-, and our positive bus bar is separated. So we have a bus bar that gets all the charging leads together, and we then have a fuse, and only after the fuse with 100 amps we go up to the battery positive. We also can see in the 3D print we have a little bulge, so we can compensate for the height of the fuse. So we had just a little closer look at the DC splice box and the chargers itself. And there's one more thing. Well, it's not a new iPhone, but we also have vents or cooling fans down here. I did include them just in case, because we will have some heat that will gather inside this compartment, and I don't want excessive heat inside here, so I have those cooling holes like in the standard belly pan, and those fans will pull out the air through those vents and suck out the heat from the chargers, or the excessive heat from the chargers, and push it down or push it out back to the rear wheel. But I think I won't need these, but in any case it's good to have them and not needing them. And we remove the seat. We actually can see the cables a little bit better. So here we have the charge cables that come from our charger down there. They go to our motor controller, and we can see our pump and our reservoir. Inside this part is a water glycol mixture, so it's a standard cooling fluid. And the other thing we can see is this little piece here. This is a breather, so a pressure equalizing element. And first off, I didn't thought I would need it, but still it gets pretty hot sometimes. The expansion of the cooling fluid and also the air pocket inside here is substantial, so it actually started leaking around here. I pressed the fluid out of the reservoir, and every time it did get cold, it pulled in more air, and my Zero did lose some cooling fluid, and it all went down the drain. Since this is not good in any way, I had to add this element, and now it will equalize the pressure inside the system, and hence I don't have any more fluid leaks on the system. But anyway, we have the pump, we have the upper part here is the output. It will push the cooled fluid down in our chill plate. And if we take a closer look, we can see it right here. This is this aluminum piece, and it goes from the back all the way to the front. And the hot cooling fluid goes back up and will go there. And below here we have the radiator with the two fans, and they will chill it, and it will come back to the reservoir and go up in here. So we already talked about the cooling loop and the radiator, and we also have two fans that will pull cold air from this area here, so above our battery and the seat area and the tank area, and they will force it through the radiator and expel it to the top of the tank and push it out to the front. We can actually see I had to do some modifications to the fins here. So we have a little mesh against insects and such. And inside this tank we actually now have an air guide that sits around, well, if you look from this position, starts around here, goes to the front, up, and follows this curve. So we don't have air circulation inside the tank that wouldn't benefit our cooling efforts. So we have fresh air that comes in from the bottom and will be expelled as hot air to the front. Also below or behind the radiator itself sits our, let's call it a brain box. Inside the brain box we have a designated controller, nothing like an Arduino or such. It's a controller that is just there for the purpose of communicating with the chargers via CAN bus, and also to communicate with the charging station. So, well, I'm in Europe, so we have the Type 2 standard, but the communication standard should be the same like the J1772 plugs you have in the US. The only difference is, we will have a closer look later, we have 230 or 400 volts on 3 phases, and if I'm correct, you have 120 volts or 240 volts, since you use the split phase system. Well, anyway, this brain box sits behind the radiator, and cables go down to the charger and to my charge port. And the charge port itself sits on the other side. As we can see, here would be the standard charge port of the Zero, and here is my new charge port. Well, this is the back side. We have the communication wire for the control pilot signal of the Type 2 communication. It is actually a loop between the CP contact and the earth contact. And we can see we have 3 orange cables. Well, this is my output to the chargers. We can see charger 1 and so on. Back here we can see the standard industrial connector. It's an M12 connector. This carries 12 volts from the chargers to our control box, and also the CAN bus communication. We also can see another cable here. This is a braided cable. This is our earth. So I take the earth and bring it to the frame of the motorcycle, like the standard charger. And since we don't have a connector here anymore, it did move to the back here. We can see it's pretty small. This is the size of my thumb. It's pretty much the size of a €2 coin. And we can also see the contacts itself are very small. Well, the datasheet says it's good for 15 or 16 amps, and the whole connection system here, or connector system, is specified to military standard. So I will have to trust the datasheet, but I'm pretty sure it will do its job. Since we have a cap, we are at IP65 or 67 here, compared to our standard connector here that was maybe IP44. And we also have a bayonet coupling, so it's a twist on, so nobody can pull out the cable while charging. The charging cable itself fits neatly inside my bag up here, and we have a standard, well, first aid kit, and we have a standard type 2 connector. Well, maybe not that standard, since this type 2 connector is shorter than the normal ones. The reason for that is quite easy. If we take a closer look at the pins itself, down there is our control pilot pin. And if we would have a standard size connector and we would try to plug this male connector inside the female connector, the control pilot pin wouldn't make contact, and as such the charger wouldn't start charging. So it's approximately 10 millimeters shorter, so we can get this pin to connect. And on the other side we have our, well, I would really like to call it proprietary connector, since this is not quite a standard connector. And as you can see, there's one pin missing. Our control system for the Type 2 and J1772 consists of two communication pins. One is the control or control pilot. This pin carries the maximum allowable current to pull or to be pulled by the vehicle. That gets dictated by the charging station. And the other pin is the proximity pilot, and this pin also only tells the vehicle and the charging station that a cable is connected. Since my brain box down here doesn't do anything with the proximity pilot signal, I just left it out on my connector. And that's pretty much everything that is there to tell about my quick charging setup. The next thing, or the next time we will see each other again, is when I go for the real test, the charging test, where I will gradually go from a few kilowatts, let's say 1.2 or 2 kilowatts, up to the expected 10 kilowatts, 9.9 kilowatts. And we will look at the motorcycle and each electrical connection with an infrared camera to see if something gets too hot. But I expect nothing to get too hot, but we will see. So, thanks for watching, and I will see you next time. Bye!